Hey everybody, happy Friday Junior, otherwise known as Thursday. Amy, did you want to kick things off or do you want me to go? I know we just
You go
spoke
ahead and
about
get
this.
started.
Okay. Hey everybody, thanks for taking the time. My name is Brandon. I am head of engineering at Concurrency. It's great to connect with you guys digitally, or at least with your circular initials. I'm going to be walking through custom demand planning options, specifically for manufacturers and retailers. And I am super pumped about it. This is a really popular use case for manufacturers, for retailers, and for folks, either looking to get started with AI or just improve their business. So it's a good sweet spot. I have three specific goals, and they're all pretty basic. The first is you learn something useful. There's a lot of noise and a lot of misinformation online about demand planning and AI in general. Would love for you to learn something useful. Number two is my goal is for you to stop thinking about build or buy. And I'll get into what you should be thinking about instead. And then lastly, I hope you have a path forward, whether you're thinking about AI or demand planning in particular. So the reason demand planning is the topic of choice is because it's super valuable. It's often low-hanging fruit from a want to get started with an impactful set of technologies standpoint. It's relatively easy to automate. There are certainly some challenges, but and it's not a set it and forget it, but relative to other AI use cases, it lends itself well to full automation. It also has synergy with another use case, which is price optimization. We're not going to get into price optimization. That's a topic for another webinar, but demand planning models play very, very nicely with that application, and together they can drive a lot of value. Demand planning also produces these models that allow you to understand your business from a causal standpoint. And even if not from a causal standpoint, you still at least learn the useful correlations that allow you to take more effective action. So it's really one of the use cases that allows you to understand reality at a higher level of resolution. And the better you understand reality, the more effective your actions will be. So super useful for those reasons. Like I mentioned, it's also a gateway to higher impact AI projects. Now, the goal of demand planning, though, is pretty simple, right? We want to make more money, and we want to do that by forecasting the future demand for your product catalog, right? And you really make more money by either reducing your overbuy costs or reducing your underbuy costs, right? So on the overbuy cost side, that's things like increasing your inventory turns, decreasing your carrying costs because you're more effectively allocating capital to your inventory. And on the reduction of the underbuy side, this is stockouts, right? If you're a retailer, that's typically what you call them. That allows you to stop foregoing revenue because you didn't have product to sell, right? Increasing your revenue, margin, and hopefully NOI. But who are we anyways, right? Who is Concurrency? So we've helped a number of organizations with custom AI demand planning. On the slide here is an example of how we helped a large restaurant chain save a bunch of money basically by better forecasting demand for their entrees. So essentially, the big problem that they had was, they've got almost 700 stores across most of the country. The store managers at each of those stores are responsible for creating schedules for their employees, and those schedules, when they're going to work, those are reliant on expectations of how many people are going to show up for dinner that night, right? Or at a particular hour. And so the managers weren't as good as they could have been in doing that. And it led to a lot of excess wasted labor. Or so basically people were staffing empty restaurants, or on the flip side, they had longer customer wait times because there weren't enough people to to staff. So we came in and we helped. We essentially built them a system to predict how many people were going to eat out at a particular hour for each of their product lines, right? So like eating in, dining out, etc., for every one of their restaurants. What was unique about this project is that we used local weather demand and local event data in the predictors, right? So if there's a big football game coming up, that's certainly going to affect, or to what degree is it going to affect people going out to eat? And then weather was used as well. Now it was a fully automated solution in that basically going end to end from raw data to useful prediction of how many entrees are going to be eaten at a particular hour. That was all automated. There were certain cases where you want to take it offline and do some work, but by and large was automated. And as you can guess, the result of this was that saved them a bunch of money. Basically, the ROI was backed into by comparing store manager forecasts with the new system forecasts, and the system that we built was not over forecasting as often and not under forecasting, resulting in a missed revenue opportunity. Also, before I continue, I should say, feel free to reach out in the chat with any questions you have. And if I see them, I'll answer them right away or get to them at the end. Okay, so similar use case. We helped basically a large furniture retailer forecast how many couches were going to be purchased in the future. Saved them a bunch of money, right, for the same reasons. This one was unique in that the forecast horizon was so far out. It was really 10 to 26 weeks, which is right on the cusp of as far out as you can go for even relatively stable businesses. And we'll get into more of that in a minute. So I'm not going to drain this whole slide, but what was unique about this was how we were able to help this furniture retailer address really stubborn problems that historically they hadn't been able to address, right? Specifically, intermittent demand, right? When consumers buy things in sort of fits and starts, it makes it really hard to predict. And we didn't have a perfect solution. That perfect solution to intermittent demand does not exist. You can ask Walmart or Amazon or any of the large retailers that, but we were able to go a long way in addressing that. There are other things like erratic or lumpy demand, and I'll get into some of the fun words for that in a bit. But in general, we save them money. They have over 100 stores. It's more accurate than the human supply chain analyst forecasts. And I should say the other thing that was unique about this project was how we were brought in to automate this decision, right? This decision of should we buy more couches right now or not, in part because the supply chain analysts weren't using the existing technology that they had access to, right? So they already had tools and forecasts, but they didn't trust it, right? They didn't trust it because they didn't understand how it worked. And so this was a big part of what we did on this project too, is surfacing why the system is making a prediction so that people can trust it and reason about if it's worth trusting or not. All right, and then the last thing I'm going to share is essentially how we helped Kroger out with their labor schedules by adding weather information into their forecasts of grocery demand. They're obviously at a huge scale. They're the largest traditional grocery retailer in the country, and so any percentage point that you save them in excess labor is a very big number. So this was a very fun project. All right, so I'm going to dive into what we actually mean when we talk about forecasting, because there's a lot of different flavors of forecasting. There's really execution forecasting. This is on the short short end, the near term side. So if you're forecasting anywhere from, sub 2 months, this is sometimes called demand sensing as well. But it really supports things like price optimization and very local inventory replenishment, and doing things like order promising. As soon as we shift beyond and we look beyond that 8-week mark, and we're forecasting from 9 weeks to up to a year, we're doing more operational forecasting, right? So it's similar to execution forecasting. It does support inventory allocation, some procurement promotion planning, but these are higher order things, right? Promotion planning, that need stability and sort of foundation of expectations that execution forecasting just can't support. And then anything beyond that is more strategic forecasting. And we're not going to get into that, but these are things like, or this is really an activity that supports things like, rationalizing your product offerings, or figuring out what markets to expand into from a product portfolio standpoint. Doing things like capacity planning, all super important activities, but not in the purview of the forecasting that I'm going to spend most of our time talking about. All right, so there are three applications of demand planning models, and they're often lumped together. So I'm going to mince them apart and spend a little time on some of the nuance, because it's an important part of value creation with these demand planning models. So the first application that demand planning unlocks is what you think about. This is inventory planning, right? It addresses things like, hey, how many couches do I need in the next 26 across the next 26 weeks, or how many widgets am I going to need in the next 6, right? This is all inventory planning. Allows you to buy new stock in expectation of satisfying imminent demand. The next application of demand planning, though, is market response analysis. This is a little more rare for a variety of reasons, but it's essentially elasticities of demand, right? If I charge X% more for this couch or for this component, what's going to happen? Are more people going to buy it or less? So this is really about figuring out how elastic your product portfolio is. And of course, as you can imagine, relies on pricing information, right? So it relies on observing different prices for the same product at different points in time, or even at the same point in time, in order to observe different levels of demand at those different price points. Not everybody has access to that, because not all products go on sale, and that might not be a part of your strategy. The last thing that, or really the third application that demand planning unlocks is price optimization, like we talked about. So given that you now know why your demand moves in the ways that it does, how can we adjust our pricing, right? This sounds really similar to market response analysis. It's really market response analysis and demand planning are both inputs to price optimization. So demand planning is often a precursor to your pricing optimization work. And I know I'm rolling through stuff kind of fast, but like I said, feel free to add information or ask your questions in the chat. Okay, so the core tasks of demand planning really depend, are point forecasting and probabilistic forecasting, right? So both are important. Most people forget about the second one, probabilistic forecasting. This is, hey, I predict that anywhere between 12 and 15 couches are going to be demanded tomorrow, right? There's an upper and a lower prediction interval. Point forecasting is just the number in the middle of that bound. Not blowing anybody's mind here, but with this, but you can also do scenario evaluation, right? So what happens if X happens, right? Where X is something within the demand model, right? So if you're accounting for things like price variation, for example, you can say, well, what if price goes up by X%? What's going to happen to demand? Or if you have your marketing campaign information, or sometimes like called marketing effort, if you have marketing effort as a driver of demand, and you say, well, what if I exert less marketing effort in the next time period? What's going to happen? That's all scenario evaluation. And then decomposition is really just breaking. You take say you forecast a wave, right, of demand over some time horizon. Decomposition is basically just deconstructing that wave into constituent parts that helps you understand demand. So what are the seasonal parts? What are the trends? And so on. Okay, so each of these are important to do. And I want to point out that each of these tasks often need to be performed at different levels of granularity across different time horizons, different levels of accuracy or demand patterns, and even downstream use cases. And so it's conceptually possible to do all of these things with one. It's common really to build multiple specialized models for different use cases. And I'm going to say more on that in a bit. Okay, so what goes in to demand planning? Typically, there are 4 different archetypes of inputs, or in machine learning land, we call them features. But those 4 inputs are pricing information, historical sales information, or historical demand information. Whatever the thing is that you're trying to predict in the future, an input is the history of that input, right? The third thing is product taxonomy. What category does this SKU belong to? What subcategory, and so on. And then lastly, the 4th archetype of input is temporal information, or stuff you get from the calendar, right? So what hour of the day is it? What's the day of the week, day of the month, etc. Now, pricing is typically among the most important factors that influence demand on products and services. So super important to include that. But it's often the input that people don't have data on in general, or reliable data in the case that they do have it. And there's a lot of good reasons for that. But it's often one of the things that you just don't include because it's data quality stuff. Okay, so typically you can expect to see the same pattern in terms of which of those inputs are more important than the other. And this isn't like a rule, but it's just a general sort of heuristic for what you can expect. So essentially price tends to be the most important. Historical demand is also super important. And then you get some calendar features like the week before moving into product catalog, and then you get sort of lower level calendar features as even less important. Now, this is obviously a general abstraction for what's important. There are lots of custom, very bespoke drivers of your business that can and often do get included into models that would also show up in a graph like this. Okay, so I mentioned some funny words before, lumpy, erratic, intermittent, smooth. These are rather the 4 ways of characterizing demand, right? And so you essentially have smooth demand, which is up here in the upper left, right, where you get this nice, very stable, very smooth demand levels. And that's obviously pretty easy to predict, right? There's a lot of consistency there, and it's easy for our models to learn the patterns. Now, imagine though you get a little more variability in your timing, and you get demand that's called erratic, right? So so essentially it could be stable if the peaks and valleys weren't quite as high or weren't quite as low. It makes predicting demand tricky. If we move down to the lower left though, and it's very variable in terms of demand, but it's relatively fixed, the magnitudes, you get what's called intermittent demand. This is also super thorny. It's quite common. In fact, I've never worked with a product catalog that didn't have any of these sort of unwanted patterns. And then lastly, you get lumpy demand. It's kind of a mix of erratic and intermittent. And these are all important to address because the degree to which your data exhibits these patterns will drive so much of the project complexity, so much of the project cost will go into handling each of these demand patterns in a responsible, sort of managed way. And the first way that you can sort of manage this is by classifying them, right? So you got a bunch of input, you've got your historical sales or historical demand information, and now you need to classify what product belongs to what kind of demand over what time frame. And you can do that through something called coefficient of variation and ADI. These are just technical ways of sort of creating that taxonomy. Excuse me. I should say too, there is a very rich literature on different ways of classifying demand. This is a very basic way, but it's often very effective. So no need to, if it ain't broke, don't fix it. Okay, so this is a depiction of what you do if. Let me back up a step here. Okay, so on this graph on the right, each one of those dots is a skew that you want to predict, or skew you want to predict, right? There are 12 or 13,000 dots on this picture. Notice, and the quadrants here represent the demand pattern, right? Notice how tiny smooth is down here, and demand is huge. You've got lumpy and erratic. Now what's happening here is you take 13,000 products and you say, well, of those, how many can I predict very reliably because they're demanded very consistently? Well, it represents a pretty small subset of your overall product catalog. And also, by the way, because they're the most stable, they're probably the least valuable to forecast, right? You can take simple averages and get a pretty good and sufficiently good estimate without doing anything fancy. Now, the vast majority of your product catalog is going to be lumpy, intermittent, or erratic, and that's trickier, right? And so you have to do a number of things, or you can do a number of things to expand your forecast coverage, right? There are going to be products that you just cannot forecast for because they are too tricky, right? You can think of a new product, right? Something that you haven't sold before. Maybe it's a new lazy boy. It's a new couch, right? A new chair. Well, how do you forecast demand for something that you haven't had history to learn sort of patterns on? Well, one way of doing that is saying, well, how similar is this new lazy boy to other lazy boys, and how well have those lazy boys sold? You can basically draw relationships like that and attempt to forecast it. Now, it's introducing a lot of complexity for a good maybe it'll work, but often it does work, but there are diminishing returns, right? And so essentially, this graph shows that trade-off of I can forecast everything, or sorry, I can forecast everything, but the quality on average would be pretty low, or I can forecast a very small or a smaller subset of the product catalog, but have a very high accuracy, right? And so there are trade-offs here. Each of these zones represents a different technique you can do to expand the fraction of your product catalog that you're forecasting for, right? So fast moving products, attribute expansion, and similarity expansion. These are essentially variants of what I mentioned before with, hey, this is a new product. I haven't sold it before. Draw a relationship between it and existing products, and then use the history of those existing products or forecasts of those existing products to forecast this new thing. The difference here is you're either doing it for similar attributes or more generally similarity across everything. All right, so just to kind of break this down, this is a fairly technical slide, so I think I might just kind of cruise through it. But the terminology here is kind of important as you get into the weeds. And so imagine the most obvious thing, right? If we're right here, this gray line, this is the time of forecast, right? Our forecasting time. And we've got this whole wiggly line called our forecast horizon, and we make a forecast, and that's our demand forecast suite. So if we look in the rearview mirror, we've got this look back horizon. And that really forms the basis of what we're doing. Now, at the time of forecast, we're basically taking all of the data available to us that drives demand, and we're piping it into our model, and it's producing a forecast suite. It gets more complicated though, because you can pull those data points that you're using to make your forecast from different points in time in the past and at different levels of granularity, depending on what kind of feature it is. And so you can think of this as essentially taking historical values that do affect sort of future values and just figuring out how long back you need to look to find something useful. Okay, so if we were to put all of that into a bad slide with too small of text, it would look like this. It's essentially an end-to-end flow of one of these solutions, right? So at the top, you basically have stuff you want to forecast. At the bottom, you get all of the value from it, right? You've got your inventory planning use case, market response analysis, scenario evaluation, et cetera. And let's say, you want to pipe it all into a pricing optimization platform. Sweet. Well, in between, you have all this stuff that you might go through to convert the data into something useful, right? So the first would be obviously finding those items that you want to forecast that are actually active right now. Not everything that you have sold, you still sell. So obviously important to find the active ones. If they are inactive, put them off to the side. If they are active though, you want to first classify that demand, right? You put it into this first blue box and you figure out what's intermittent, what's smooth, and so on. Then you're going to basically take different actions depending on what kind of demand it is, right? And so if it's lumpy, you're going to put those items into a specialized model to handle the lumpy stuff. If it's not lumpy, then you're going to essentially dump it into the next step and see if you can basically, if the intermittent and erratic stuff is sufficiently similar from a product standpoint to treat them the same or differently. If they're different, you put the sufficiently different ones over to the right in the same bucket. You move the inactive ones, and then for those that remain, you do what's called feature engineering, which is essentially connecting with your business stakeholders and understanding what might plausibly drive demand for various things, and building a data set around them, and then sort of piping them into the model, right? And you finally get your model, and out comes useful stuff. All right, that's super high level. Now, I said I want you guys to leave not thinking about build or buy. Instead, I think it's more effective to think about what to build and what to buy. Not everything is created equal, and it's important to know what's what, especially for all technology solutions, but especially AI technology solutions like demand planning. And so what I like to do with our customers is work through a map that's shown here that can help them reason about which components under the hood they should be buying or they should be building. And if they do build them, should they build them in-house or with an external partner? Now, this map kind of has a lot going on, but at the top, you start by pointing out the business value, the reason behind all of this technology, right? Well, demand planning, this is for healthy working capital, right? We said at the top of the call that demand planning is to make more money, right? By reducing overbuy or underbuy costs. That's all about healthy working capital. In order, and then basically everything below that is a component required to make it happen, right? And then you basically position each of those components on the graph where you're mapping that component's position and that component's movement, right? Position and movement closely related, very important to talk through. Basically, the vertical axis is that value chain. So the higher up is, the more valuable it is to users in the business. And the horizontal axis is the maturity of the component, right, in terms of technology, right? So on the far left, you'd have like brand new ideas. Nobody's kicked tires on it yet. That's your POC kind of stuff. On the very far right, these are utilities, right? This is like electricity, right? Where electricity is like very, very much utility, and nobody ever thinks about utility. So it's all the way down here. Now, going back up to healthy working capital, in order for that to happen, you need to decrease your carrying costs. In order to do that, you need better inventory turns. And in order for that to happen, first of all, you need something to track ROI, and you need a CRUD app to change inventory levels, right? In order to change inventory levels, you need an ERP integration, which needs a platform, which needs a compute, which needs energy, and so on. Now, I'm going to point out a few different things, right? So all of this in red is the stuff that's not AI related, right? There are huge portions of this system that you do not need a data scientist for, right? Nor should you hire one. It's very sort of classic. So CRUD, that's a great question. Stands for create, read, update, and delete. Any software basically that lets you interact with it is a CRUD app. It's got an unfortunate acronym, but that's what it is. Great question. So the stuff in red is the AI disabled portions. ROI tracking, basically a UI to change the inventory, an ERP integration, which needs business logic. The ERP integration obviously needs a platform. That platform needs ETL to get some historical data. And that's, obviously all being computed. All right, so this is important to talk about, but it's the not as interesting stuff. This stuff in red is the stuff related to the AI demand planning portion of the system, right? And so obviously what's very visible and often not mature at all that you need for demand planning, those are the forecasts themselves, right? Not the forecast model, but the output, right? In order for that output to be useful, it needs to be explainable. This is its own section. Really, in order for those forecasts to be produced, you do need some business logic. You also need the actual forecasting model. The forecasting model then needs a few different kinds of data points, right? Those four really that I talked about before, which would be product taxonomy data, historical demand data, price data. All of those things needs ETL and an ML ops platform, right? Something to make this automated and well governed. And both of those things need a platform. Now, there are two other sources of data up here. There's weather data and calendar data. Notice how each of these data sources and each of these components, they're in a different position in space. And this is really important because it's going to make or break if you buy them or build them. And so kind of to help illustrate this, I put some colors here, basically just to highlight the different zones of tech maturity. So, the brand new stuff called Genesis, then you've got sort of this custom built lane, then you move into more configured product world, and then finally you're in utility space. All right, so you want to, every organization is different, and I'll kind of get into how to think through some of this, or how I've found it useful to think through some of this. But typically you'd want to build the Genesis and the custom built stuff, right? That is sufficiently sort of high value in the value chain. There are components though that may not be worth building, right? And those are the things that you might want to configure, right? There are components that aren't totally off the shelf that you can buy, but maybe they're open source and you can stand on the shoulders of giants and just kind of configure them. Saves you a bunch of time and money. And then lastly, you're in the utility space where it is not worth anybody's time to configure or build this stuff, right? It's just buy it off the shelf. That's fine, right? Like nobody's going to go out and build their own generators to produce their own electricity, for example, right? That makes no sense. Same with compute. Calendar data is basically the same. Okay. So this maps out really what you should buy, configure, build, but it doesn't really say much about who should do that. And it feels like a basic question, but there aren't a lot of good resources that I found to help you walk through it. And so I made this decision tree to really map how I think about and how I guide customers on their build versus buy journey. And so the first preference is buying off the shelf, right? And there are exceptions to this, but a good starting default would be buy things off the shelf if certain things are true. The second preference would be to build internally, right? It's good to own stuff, especially the important stuff. The last preference would be to build with a partner. Now, each of these things happens under different scenarios. And so the first question that's important to start with that helps inform which component should be built by or bought by which party is this component a competitive advantage, right? And if it's not, then the next question is, does it need customization or flexibility? Now, if it doesn't, buy it off the shelf, right? Not worth it otherwise. In the event that it needs customization and flexibility, the next question here is, does it impact really strategic stuff or the customer, right? If it doesn't, buy it off the shelf. If it does, the next question is, well, can I build it in-house? And that's a question of, do you have the people with the skill set to build the thing? If you don't, build with a partner. Now, if you can build it in-house, there are cases where you build internally, but there's also a point in time where just because you can doesn't mean you should, and we'll get to those. So the next question is basically, do you need it fast, right? Do you need a really fast time to market where you can't afford really to have folks kind of like learning how it's done? If you don't need it fast, you can choose to build internally. And that's not to say it's definitely going to be slow, of course. If you do need it quickly and you prefer to sort of trade the long-term costs with investment up front, and you have a culture of innovation, build with a partner, right? If you don't have a culture of innovation, but those other things are true, then you can buy off the shelf. So this is a set of heuristics that I found to be useful for organizations who are still thinking through like what to build and what to buy. It's not right all the time, but it's a pretty good start. All right, just checking the other questions. All right, so some challenges with demand planning systems. It is not without challenges. Click through this. So first of all, out of stock events do bias demand data, right? So if you can't observe, or if you don't observe, if you don't have the opportunity to see how many things would have been purchased because it wasn't available, you're not going to know how to treat that, right? Like just because you didn't have demand doesn't mean there wouldn't have been. And so that's a tricky thing that needs to be addressed with some fancy statistics. The next thing is really reconciliation of the hierarchy, right? You've got a product catalog, you've got things that belong to different categories and subcategories. And if you forecast at the SKU level, right, I need 14 of these couches and 7 of those, they need to roll up. They need to be able to be aggregated to that category or subcategory or whatever your preferred level of abstraction is in a way that's compatible with like your constraints, basically, right? Sometimes you can forecast at the category level. It's often something that we do. And then you have to spread that group level forecast down to specific SKUs. And you only need to do that in cases where the SKU itself doesn't have sufficient signal or volume to warrant just to really warrant forecasting it on its own. But anyways, this is a tricky thing that needs to be dealt with. Another challenge is what we talked about before with limited catalog coverage, right? You don't have enough high quality signal to forecast for a sufficiently large fraction of your product catalog. And so what do? There's the forecasting of new products, right? This is called the cold start problem. I mentioned it before. There's a lot of things that you can do to handle that, and it's deeply technical, so I didn't want to get into it. Another challenge is data related, of course, right? So quality data is a challenge here. Typically, most often with price. And for a variety of reasons, right? Pricing is often one of the most complicated, very custom activities that an organization goes through, and it results in suspect data that you may want to think better of if you include it into your data forecast models. It's often so related to price. Sometimes you don't have price variability, especially if you're a B2B organization, right? So by price variability, I mean you don't have cases where you sold a SKU for price X and price X minus Y, right? You didn't sell the same thing at different prices, and so you can't draw a relationship between changes in price and changes in volume. You just see changes in volume, but you have the same price, so not much you can do about that. Another challenge is this is really a challenge from my point of view as a third party coming into another organization and seeing what could be done to create value. Low adoption of price optimization. Price optimization is not surprisingly super important, right? It drives really fundamental things of your business. And despite this, there's often low adoption of this very, very valuable technology. All right, so a little clickbaity title of mine, some stuff you should know. Often folks want to know upfront how much of their product catalog they can forecast, right? For reasons I talked about here, we can't know that upfront. It's impossible to know how many of your products can be forecasted before we forecast them. We can make reasonable judgments about it, but really, this is the last thing that we can conclude. And so there are certain heuristics that we can go through to help make an informed and conservative sort of judgment on this, but empirically you can't know until the end. Now, similar to what I mentioned with that use case with the furniture manufacturer, demand planning forecasts are super easy to veto by people. Demand planning tools are often not built to be autonomous decision-making tools. They're decision support tools, and so it relies on a human to read its output and take action on it. And for reasons related to poor implementations or distrust, often people ignore them. So it does require change management. Super important. Some projects don't need it. Some projects do. Demand planning is one where it definitely does, because it's definitely a people product. Demand planning is often neglected. It's not sexy. It's been around forever, and I think that's unfortunate. Also, what happens is these projects can fail, even if it's not a technical thing, if they lack a champion. And by champion, I don't mean just a sponsor, but I do mean somebody who is going to go to the mat and really evangelize for this technology. That's super important. Also, it's not a panacea solution. Demand planning is only worth it if the future is expected to look like the past, right? Demand planning is a tool that learns the past so that it can predict the future. That only works if they're expected to be the same. So if your business isn't stable, forecasting is not great. Okay, so stuff that affects the scope of these projects. There's a lot. So really the state of the data, how complex is the data processing? What does the pricing data look like? Where is it all at? Does it require a lot of integrations and so on? Another driver here is basically the demand patterns, right? How lumpy and erratic and intermittent is this? This can be backed into relatively easy just by looking at a single data source often, which is the historical demand. Another thing that's tricky is deciding if and how you are going to address that cold start problem and slow moving items problem, right? So the cold start is that you have a brand new product for the first time and you want to sell it. How do you forecast something that you haven't sold before? And slow moving items, these are related to lumpy products. The more technically you try to address these problems, the wider the scope. Another thing is, how human readable do you want or need the output? If you don't need it human readable, then that's less work, right? If you need it very human readable, that's more work. The good news is there's lots of things that can be basically built and recycled to facilitate this effort. And then another thing I think that's important is for organizations to think about when they undertake one of these projects is, how much do you want to learn about your business? How much do you want to kind of roam and explore different things that you might find interesting? This is an often and understandably overlooked section of these projects, but one of the higher leverage activities. All right, so what comes next? We're offering an AI envisioning session with myself and our CTO to do an AI envisioning session, right? So this is zooming out of just demand planning, and it's aligning the organization on strategic objectives, fielding different pain points, different opportunities to improve, and sharing the state of what could be possible with various AI solutions. This has been super popular, and it's a very, very good high leverage activity to get started with AI stuff if you're brand new. Also, we're doing complimentary 2-hour deep dive sessions into demand planning in particular. If what you learned today was interesting, or if you have specific questions, that could be something to check out. And then lastly, we are offering a complimentary Microsoft funding review. So, what kind of funding from Microsoft would be available should you decide to go down this path. So, good next steps. Also, I should say you can reach out to me if you're interested in chatting. Otherwise, there will be a survey after this, I believe, Amy, if that's right, to
Yeah,
kind of capture
I put a
information.
survey, and I put a link to a survey. If you're interested in any of these, if you want to just fill that out, we'll be in touch.
Yes, and with that, I want to thank everybody for your time. Appreciate you being generous with it on a Friday Junior, and I hope to see you around. Thanks.